Hello, in this video I'm going to show how to simulate a simple half-bridge converter in MATLAB Simulink with SimEscape toolbox. First I need a voltage source, voltage source. I'm using SimEscape and specialized technology. So voltage measurement I will need voltage source, DC voltage source from specialized technology, and power GUI. Discrete, and I will put 10 volts for each, and I will divide the DC link into half. Ground for the midpoint. Just make sure that you are taking all the components from specialized technology of SimEscape, IGBT diode from specialized technology, fundamental blocks, power electronics. Just Control R will rotate and Control I will mirror your components. This is my and for the load I will use RLC branch, and for now my load is just resistive. And I will connect it to the midpoint. Now here is my AC terminal, this is my DC link, and I will measure the output voltage. Also I would like to measure the output current, so current measurement from specialized technology. I need to put current in series, current meter in series. I'll use go to make it a little bit tidy, and I'll name it IO and this one as VO. What else I need? I need to give these some signals. It's from, I'll call it G1. Later I will define the go-to for G1, and it's again from, I will name it G2. These are my gating signals, and I will need a scope to show the results. For in the scope I will show IO, VO, and maybe G1. The first gate I would like to show the gating signal and see with the gating signal what happens to my current, voltage, and the okay. Now for gating signals, I am defining a pulse generator. I will use simply a pulse generator for now. Later on we can do a pulse with modulation. With a pulse generator I will double click on it, and I will use time-based one. Amplitude is 1 and period it should be 1/f, my period, and I assume that my frequency is 100 Hertz. 50% on and 50% off, half duty cycle. So I will use the go-to for this, and I will use a logical operator and not when you use the logical operator, it gives the complementary, because these switches are complementary. So I can get the go-to for G2. So I think we are good. We can run the simulation and check the figures. I'll zoom in for a little bit and check. Oh, when it's G1, this is the very top one is G1, so it's my first upper switch gating signal. When the upper switch is on, my voltage, I can see that it's 10 volts, the DC half DC voltage, and negative half DC voltage when it is off, and here the other switch G2 is on, because they are complementary and my voltage is negative. I can see in this half cycle. Also the output, I think one of them is, maybe the second one is current. Yeah, this is the current and this is the voltage. Because it's a resistive load and it's 1 ohm, they will be the same. Now I'm gonna change my load to a RL load, and I'll add some inductance to my load. And again, check my signals. I can see that the voltage won't change, but adding an inductor will smoothen the current, and it will be more like into sinusoidal and AC current. Now, to make it more AC, I will do quickly a very simple pulse width modulation technique. For doing that, I'll go to Simulink library and I'll find some sources here. What I need is from sources, I will take the repeating sequence. One. I will need a logical operator too here, maybe math operations or logic operations. Yeah. Relational operator. And I will need a sine signal too. So I think in math operations, sine wave, or in sources, sine wave. Okay. That's what I need for doing instead of pulse generator, I will do pulse width modulation. Now my sine wave is time based, and I am using, you can use external signal for simulation time. I'm using just simulation time for this. Amplitude is 1, and my frequency, it's the output frequency for my signal that I wish to have. It's, I'll say, and it's radian per second, so it's my omega, which is 2 pi F, my frequency, 2 pi frequency, and my frequency, I assume that I have a 60 Hertz sinusoidal output. Then for this one, this is my carrier frequency and signal, and carrier frequency determines my switching frequency. I will use 1 over, for now I'll just use 100 Hertz, 1 over F, and here from -1 to 1, because my sign is between -1 and 1. And when my sign is higher than the carrier, so this should be on, the upper switch, and otherwise the lower switch will be on. I would like also to check my signals here, so I will add this one, sine wave, and this one. I can run the simulation now and see. I can see that my current is more sinusoidal now, and I will check the voltage, the signals here for pulse width modulation. For better understanding, I will put these two in one figure and check. Okay, I can see that when my sign is higher than the carrier, my upper switch is on, and otherwise it's off. So this is working properly. I will just increase the frequency, switching frequency, a little bit more, like 10 times. I will use 1 kilohertz now, 1000, and I'll see what happens to my current. I expect to see more sinusoidal current, and now I can see that my current is more sinusoidal. And if you take the fast average of your voltage, it will be also a sinusoidal wave. In next videos, I will do a little bit more operations here and change this sinusoidal PWM. We can use also modulation technique, modulation index M, and define those to create my sinusoidal waves here, to do the pulse width modulation here in this part. Also, from the Simulink library, there is I think in SimEscape in newer versions, use fundamental blocks, and here power electronics. Pulse and signal generators. I think here it does the PWM generator 2 level. It does the same for you, this operator. You can just use this block instead of this part. Also, you can find, instead of the repeating sequence, you can use this block, Saltos generator. I think this one is more easier to work with, because you give the frequency and phase degrees and it will do all the things to you. I can just use this quickly. I will, 1000 Hertz for frequency, and just leave this 0. I can see that I'll get exactly the same figures.